We're going to go through a video here on graphing a higher order polynomial. This example has multiple steps in it. Please take your time and pause if you need to. This function is f of x equals negative 5x squared minus x cubed. I would first want to change it to a standard form, so I'm going to put it in descending order. So I'm going to flip-flop the terms on the right, so it's negative x cubed and then minus 5x squared. Now step one, we want to identify that end behavior, so we're going to look at the leading coefficient test. We look at the degree. The degree is 3, and its leading coefficient is a negative. Our degree is 3, which is odd. The leading coefficient is a negative, so what will happen to this graph? What happens on the right? What happens on the left? So that leading coefficient test you already have in your notes. On the left-hand side, it's going to rise. And on the right-hand side, it's going to fall. So it'll look something like this, which we know is the shape of a snake, and that's a cubic function. Next, we want to find the zeros of the function. Remember, those zeros of the function are the x-intercepts. So we're going to set that function equal to 0 and solve for x. So we're trifactoring it. So we say 0 equals negative x cubed minus 5x squared. The number one rule to factoring is to see if there's a GCF, which there is. A negative x squared can be pulled out, divided out, factored out. So we're left with an x plus 5. Now I'm going to set each of the factors equal to 0 and solve for x. So negative x squared equals 0. Square root both sides. And we get x equals 0. Notice this is a repeated 0 because of the squared. And its multiplicity is 2, which is even. So if we look back to this previous video, when the multiplicity is even, it's circling again in purple, it's going to touch that x-axis but not go through it. That's going to help us when we start graphing this function. When the multiplicity is 2, which is even, it's going to touch the x-axis but not go through it. The other factor is x plus 5. That is not a repeated 0, so we just solve it for x. We get x minus 5. X equals negative 5. So here are my 3 zeros. I have a repeated 0 at 0 and then another 0 at negative 5. Let's go out and identify the x-intercepts. Remember, the x-intercepts are the zeros of the function. So we have an ordered pair at 0, 0, and then another ordered pair at negative 5, 0. Step 4, identify if this function has any symmetry. So if I want to check for symmetry with the x-axis, I'm going to replace the y with a negative. So negative y equals negative 5x squared minus x cubed. Do you get your original function back? No. For x-axis symmetry, I'm going to replace the x with a negative. Simplify it. Negative x is positive x squared. Negative x times negative x times negative x multiplied by negative 1 is positive x cubed. Do I get my original function back? No. Last one is negative x, negative y. Negative y equals negative 5. Positive x squared, positive x cubed. Take out a negative 1 from the right-hand side. Turns that to a positive 5x squared and a negative x cubed. If I divide both sides by negative 1, I get y equals 5x squared minus x cubed. I did not get the original back. I should have put no here and no here. So unfortunately we have no symmetry with this problem to help us with some points. Now we're going to plot a few additional points around the x-axis. So I'm going to skip this number 5 and go out and graph some things first. I'm going to graph those intercepts. So I'm going to graph the intercept 0, 0. And then I'm going to graph the intercept negative 5, 0. Now if I remember my end behavior tells me that on the left-hand side, I'm going to rise. So on my left-hand side, if this is my left-hand side of my graph, I'm going to rise. So if here's my x-intercept, this must come up. Then on my right-hand side, what did it say it must do? It has to fall due to that leading coefficient test. So my farthest x-intercept on the right must fall. The right-hand side falls. Now I know that shape of that graph for a cubic function, f of x equals x cubed, is a cubic. Its shape is a snake. So now we're going to just try a few additional points within this function. So you may want to try like negative 4, negative 3, negative 2, negative 1, somewhere within this region right here, to see what's happening in between that. I know I can't go anywhere else within that yellow region. So I'm going to evaluate the function. So my function was negative x cubed minus 5x squared. Negative x cubed minus 5x squared. Better make sure I have that right. Negative x cubed minus 5x squared. Okay, so I'm just going to pick just a couple additional points within my x-axis in the yellow here. So I'm going to just try like negative 1, negative 2. So I plug in negative 2 into the function. I'll just go off to the side here. Y equals negative 2 cubed minus 5 times negative 2 squared. Negative 2 times negative 2 times negative 2 is negative 8. Negative 8 times negative 8 is positive 8. And then negative 2 times negative 2 is positive 2. Times negative 5 is negative 8. Sorry, negative 10, which is negative 2. So that ordered pair we get when we graph. Let me erase this yellow and red stuff here. At negative 2, we're down at negative 2. Remember also with that blue piece, you cannot cross the line, the horizontal axis. You may want to try maybe one more point to see kind of how far it goes down. And then it has to come back up. And that's how you can graph a higher order polynomial.